Hello friends, welcome back to my YouTube channel. Today we will learn another important numerical problem from projectile motion. After solving 8 different problems, we became a little bit expert in the subject matter of projectile motion. Now let us see a little bit confusing and a little bit difficult type of question from projectile motion. This question was asked number of times in your final examinations. Now let us see our question. A batter hits a baseball so that it leaves the bat with an initial speed 37 meter per second at an angle 53 degree. Find the position of the ball and magnitude and the direction of its velocity after 2 seconds. Treat baseball as a projectile. This term, treat baseball as a projectile, it means we are neglecting all air resistance and there is only one force, that is force due to gravity. So our A will be plus G or minus G depending on this situation. In this condition our baseball is going up, so our A will be minus G and X component of velocity will remain constant because this is projectile motion. Before solving this question you should know the derivation of projectile motion, the basic concept of projectile motion that we already discussed in previous video. Now velocity of projection is 37 meter per second and angle of projection is 53 degree, and this question is asking us to find position of ball after 2 seconds, velocity of ball after 2 seconds and direction of the ball after 2 seconds. So after 2 seconds we need to find position, velocity and direction of the ball. Now let us see, this is a baseball and this is flying, this is going somewhere in air. It has some initial velocity towards x-axis u cos theta and some initial velocity towards y-axis u sin theta, and this u is the resultant velocity or the velocity of projection and this theta is angle of projection. After 2 seconds we can consider the position of projectile anywhere here, anywhere in its path. So let P be the point here. According to this question we need to find the position. It means the x distance travel towards x-axis comma distance travel towards y-axis, P x comma y, that is the first part, and the second part is what is the velocity or resultant velocity at point P. Now let us solve this stepwise step. First part is x component of velocity. This is initial x component of velocity, that is u cos theta. U is 37, cos 53, that will give us 22.27 meter per second, and y component of velocity is u sin theta, that will give us 29.55 meter per second. But after 2 seconds y component of velocity changes but x component remains as it is, because in projectile motion x component of velocity remains same. After 2 seconds, after 3 seconds, or whatever be the position, x component of velocity remains same. Y component changes and formula is v is equal to u plus at. Here u a is minus g and t is as it is. Our uy is 29.55. By solving this we get y component of velocity as 9.55 meter per second. Now let us find the position of baseball after 2 seconds. After 2 seconds x position will be, our formula is s is equal to ut plus half at square, but if I write x here our a will be 0, because in projectile motion the acceleration towards x-axis becomes 0 because of constant velocity. So x will be 44.54 meter and y will be ut minus half gt square. This is also modification of s is equal to ut plus half at square. So our y component or y distance is 39.1 meter. This is the position of projectile after 2 seconds. Now let us see the second part of this question. That question is asking its velocity. For the velocity after 2 seconds we need to calculate this v, that v is root under bx square plus by square. This bx is velocity of projectile after 2 seconds towards x-axis. This velocity is velocity of projectile after 2 seconds towards y-axis. So we already calculate vx and vy. This is the resultant velocity, and our formula to calculate direction is tan theta is equal to vy by vx. I am again repeating this part. Vy is velocity after 2 seconds towards y-axis and this is velocity towards x-axis, and we have already calculated this by solving theta, this expression, theta is equal to 10 inverse 9.55 divided by 22.27, we get our theta is 23.21 degree. Therefore required magnitude of velocity is 24.23 meter per second and direction is 23.21 degree. Thank you very much. See you in another video. All the best.